All right, guys, we got our last video here for transformations. And so I like this one. This one is a real test to see if you really get this stuff. Okay. And so what I have some graphs, okay, and our job is to find the equation of these. So work backwards. And so you know it before you think like, oh, how am I supposed to find the equation? You know everything that you're supposed to know to be able to find this, if you understood all the videos before of transformation. And so what we need to do is look at these and kind of work backwards, right? Because this was kind of the end result of what we had, right? We would graph the transformation and that would be it. But for these, we're given the graph, and so we need to work backwards and figure out, okay, what sort of graph is this? What's the parent function? And what transformations are being done to that from kind of what the normal one would be. Our big thing here is to determine these A, H, and K values, okay? Remembering what those are, what those mean, and thinking about how those would be applied to these. So this first one, okay, the process is going to be the same for the easiest ones and the most difficult ones. The process first, kind of like with when we look at an equation, our first goal for these is to identify what's the parent function, okay? And again, we don't have an equation to look at, but we have the shape of these graphs, right? And so you should be pretty good at recognizing what the different shapes of these parent functions are, right? So you look at the first one, this is a V shape, right? It's a V-shaped graph, okay? And so you should hopefully know that the V-shaped graph results from an absolute value equation, right? So we know that the equation is going to be y equals, and there's going to be an absolute value involved. We know that just by the shape of this graph. And so what also can be helpful is once you identify the parent function, just like we would do if we were given the equation, draw what the normal, just standard absolute value graph looks like, starting at the origin. Okay, and so I look and see, okay, what changes from the original to the problem here for number one. Okay, and so what we would look for, right? What we would look for are, right, these things. I would look for kind of in this A value. There's two different things we could look for. It's a flip, right? A vertical flip. Is it upside down from the original? The A value, right? If there's a 2 or a 3 or a 1/2 or whatever there, that would mean that's stretched or shrunken vertically, okay? And so that's that A value, right? The H value would mean, right, from the original, it's shifted left to right a couple spaces, and then the K value means it's shifted up or down. All it did was it shifted up, right? Because it did not flip upside down, so we know that there's not going to be a negative out in front. The shape itself is the exact same, right? It's almost like we just pushed this up. So that A value is going to be 1, or basically that means we're not going to have anything written out in front there. H, is there an H value here? And again, if it shifted left to right, there would be an H value, but it didn't, right? It's not shifted left to right. It's just shifted up. So all that's going to be in here in the absolute value is just X, okay? If it shifted horizontally at all, there would be a plus or minus a number in here, but there's not. But then there is a K value, right? There's a K value, meaning, right, it shifted up, okay? And so how much did it shift up? You think, okay, that went 1, 2, 3, 4, up 4, okay? And so you have to think, okay, up 4, that's the shift. What does that look like in my equation? And with a K value, it's pretty easy, right? It's just plus 4. But that's it. That's my equation, right? Y equals absolute value of X plus 4, okay? And a great thing to do here too is check it in Desmos. Check this in Desmos graph, type your equation that you think it is, and see if it matches with the one on the graph. I'm not going to worry about domain and range for this one just because we've done that so often in the other ones. So don't worry about domain and range. Now, number 2, again, same process. Number 2, we look at this. Okay, our goal is to find the equation, but we want to determine first, what's the parent function? Okay, what's the parent function? And the parent function here, right, we kind of look at the shape of the graph and where the points are in relation to the vertex, okay? And this would be, if you know it, it would be a square root, okay? It's kind of an upside down square root, but it's still a square root graph, right? It's that weird, it's kind of, the square root's a little different because that's the only graph that kind of comes to a stop at a certain point. And so we look at that, and so we think, okay, I know my graph is going to involve, or my equation is going to involve y equals, it's going to have that square root in it. But we need to determine, okay, is there going to be an A value, an H value, and a K value in there? And so let's sketch that too. Let's sketch what the original would look like. And again, you should be pretty good at this point. Parent function looks like, and so what we want to do is compare. How is the original compared to the one that I was given here? Okay, and what changes happened to it? Okay, so the obvious change that I see is that it's upside down, right? It's upside down. So you might know that that means there is a negative out in front, right? That's that vertical flip. a negative out in front of the equation. And so again, this can be tricky too. You might think, okay, I don't know, or there might be a vertical shift because it's kind of going down, right? All the points are kind of shifted down. That's true, but the key here is the vertex, okay? You compare the vertexes of the two. So no, there is not going to be a vertical shift, right? Even though it flipped upside down, that negative did that, okay? There's not going to be a k value added on or subtracted on the end, okay? Because it did not shift at all up or down. It shifted left 3. That means I have an h value, okay? And what would my h value be? Well, I moved left 3, right? That's my transformation that happened there, a left 3 shift. So that would mean, right, a plus 3 inside of here. Okay, a plus 3 would happen inside of there with the x, okay? And so you might think, okay, so I got a horizontal shift, I have a vertical flip. Is there going to be an a value, right? Is there a 2 there or whatever? And so what you would look for that is, are the points the same distance away from that vertex as they were in the parent function, okay? So like I moved up 1 over 1, up 2 over 4, okay? And the answer to that is no. Or yes, they are the same distance away from this vertex vertically, okay? So this is my answer. Y equals negative square root of x plus 3. So that's that one. Let me do a few more and we'll be all set. All right, got 3 and 4. So number 3, okay, number 3, we see it is this curve, right, going down, okay? So process is the same. What's the parent function here? And I would say this is most similar to a quadratic, okay, a quadratic, because, right, quadratics have that parabola shape, okay, and this is pretty different from what the original parent function is, but we're going to see that this is going to be that just with a lot of transformations in there, okay? So I'm going to draw the original quadratic, right, so that's that curve, and so I compare this to that, okay? And again, it's going to be a lot, okay? There's a lot of changes here. You might think in your head, okay, there's a lot of, obviously I see that it's different, but how do I know what the exact transformations are? Again, I like to start with the vertex. I like to think, okay, the vertex of this one is here. Where's the vertex of this one? It's all the way up here, right? The vertex is kind of the corner of the graph, okay? So that's what I called, when we were learning transformations, I called that the origin point, okay? The origin point, meaning that is kind of where I draw all my other points from. And so why that's helpful to start with is that's going to tell me, right, comparing this to this is going to tell me what my horizontal and vertical, right, my h and k values, what those are going to be, right, however many I count up and over to get to that new origin point. So what is the shift from here to here? So up 7 and left 6, okay, those are my horizontal and vertical shifts, okay? And again, those are going to mean in my equation, those are going to mean my h and k values. So let's start to piece this equation together. We're just going to piece it together like a puzzle, okay? So if it's a quadratic, the key of a quadratic, it has that 2 exponent here. So there can be an x in there, okay? But I need to put these shifts into, like, translate those from these shifts to values in my equation, okay? So up 7, again, you might remember up 7 means that's a k value. So up 7, they got the bells going off in here, and it's summertime. We don't need bells right now. Up 7 means plus 7 as a k value. And then a left 6, right, that's a horizontal shift. That's an h value. So left 6 would mean a plus 6 in here. And now it's going to be all about these a values, okay? So we need to find 2 more things. We need to determine, does it flip? And does it change the vertical distance? Is it stretched or shrunk at all? Okay, and yes, to both of those, yes. Right, you see that with the quadratic, it's a smiley face, right? It's a smiley face, and now it's a frowny face, right? So that is my way of saying, yes, it does flip. What does that mean for my equation? Well, that means there's going to be a negative out here, okay? There's a vertical flip. So I figured that out. My last thing to figure out is this a value, okay? And again, the a value would come from, right, the points being more distant vertically or changing distance vertically from the origin point, right? So normally this would be, right, if it's vertically flipped, it would go down 1 and right 1 to both sides and down 4 and right 2 to both sides. It doesn't happen that way. This is down 2 over 1 and then down 2, 4, 6, 8 and over 2 to both sides. So you might know, okay, what happens, right? Normally they go down 1 and then down 4. Now they're down 2 and down 8, okay, that means that those values, that distance is multiplied by 2. So what does that mean for a multiplier or an a value here? Well, that means it's 2, right? The distance was doubled. So that's the whole thing. That's the whole equation, okay? You see that it looks really complicated when it's a final answer. But again, you don't try to do it all at once. Just piece it together, okay? Last one here, number 4. Our first goal is to figure out what's the parent function of this, okay? What's the parent function? And this can be tricky, okay? This can be really tricky because it's pretty stretched out, right? But I will tell you that this one is a cube root. A cube root. How do you know that? Well, again, that comes from knowing your parent functions really well, okay? But also the patterns of the points, right? Let's just draw my cube root function up here, and you might be able to see that, right? Both cubic and cube root functions have those 3 points, kind of diagonal like this. Cubic goes up really tall, where cube root is a lot wider. They go over 8 up to, over 8 to the left, down to. So that is what my parent function looks like. And again, I want to compare. Okay, how does this compare to the one I was given? And again, when you have a big complicated one like this, I like to start with that origin point. For this one, it's not really like a vertex. Like this one was a vertex, so it's a little easier to see. This one is kind of, you could say that's just like the middle point, okay? And so where's the middle point in this big black curve? Well, it is right here. Because again, that's the one that's kind of right in the middle of these two. Again, I said they're evenly spaced out, so that's how you know that that's the case, okay? And so once you figure that out, then you're going to be able to figure out your H and K values, okay? You figure those out by counting, right, how many it moves up and down or left and right to get there. So just putting together kind of the skeleton or the outline of what my equation is going to be. A cube root, right? It's that radical with the 3 there, okay? There's going to be an x in here. So I'm going to fill in the a, h, and k values based on that. So let's count. I am in the middle, okay? How many does it move to get here? Well, it moves up 1, left 3, okay? Up 1, left 3, okay? Up 1 and left 3 to get from this middle origin point to this middle origin point, okay? So up 1 and left 3, again, it's similar to this one, same directions, just different numbers, okay? So up 1, that's a k value. So that's going to be a plus 1 outside of the radical, outside of a group with the x, okay? And then a left 3, that's an h value. Again, left means plus, and so plus 3 is going to be in a group with the x there. So those are my horizontal and vertical shifts. That's like half of the things I have to figure out, so that's good. Now it's just figuring out, does it flip vertically, and is it stretched or shrunken? So let's deal with the first one. Is it a vertical flip? Okay, does this kind of flip its shape? And that can be really tough to tell too. But no, this doesn't. This does not flip, okay? You see that it kind of starts out low and ends up going higher, okay? Even though it's a lot different of a shape. And that's the same thing, okay? If you remember, we talked about a vertical flip of my cube root, and I showed that in Desmos. Kind of the original kind of started low, goes higher. And then the flip version of that, it kind of starts higher and ends lower, okay? And so what we would look for with a cube root function is if it started high, went down, and ended lower, okay? So no, this does not flip vertically, okay? So there's no negative here. That's what that means. But it's definitely stretched out, okay? So let's compare, right? Again, normally it is up 1 and over 1, kind of both ways here from the origin point. So what's the vertical distance here? Well, I counted up 3 over 1 and down 3 over 1, okay? So that is a difference of 3, right? Or it would be like it was multiplied by 3. Let's just check the other ones, okay? Normally I move up 2 and over 8. Okay, this time if I times it by 3, 2, 4, 6, and over 8 to get here, okay? And then down 6 and over 8 to get there. So yes, there is, right, it's tripled. The y value distance from the origin point is tripled of what it usually is, okay? So that would be a 3 outside of there. That a value would be 3. So 3 times the cube root of x plus 3 plus 1. And that's it. Once you deal with those 4 things, h value, k value, negative, and an a value, that's it. Okay, you've checked all your things that you're supposed to, and they're all in the equation, and then you're done. Okay, and then just check in Desmos at the end to make sure it matches. Awesome. It's a really tough stuff, this unit. So if you're getting it at all, pat yourself on the back, say good job, because it is. It's really impressive to understand this stuff, especially with the virtual learning. So good job, guys. On to Unit 3 after this. So thanks for following.